The final module of Chapter 24 is going to look at a specific example of the binomial interest rate lattice. And there are many, many versions of binomial interest rate lattices, and almost all of them have the desired goal that they provide enough parametric flexibility that they allow you to price the bonds in they give you enough parametric flexibility so that you can change the parameters to reproduce the prices of zeros that you can observe in the market. You recall one of the criticisms with the short rate models was they simply didn't have enough parameter flexibility, so they might have had 3 or 4 parameters, but there are many zero coupon bonds to price. In binomial lattices, they're usually designed in such a way that there are enough parameters, so with a little bit of work and sometimes ingenuity, you can determine the value of those parameters so that at the very least you start off with a pricing model that reproduces the market price of the zeros that you observe today. And that's a pretty good start for a model for pricing options and other instruments, because at least you know you have a binomial model that can price zero coupon bonds, which is an important subset of derivative securities. The Black-Derman-Toy model is one and a popular example of such a lattice. So the models we've determined are arbitrage-free. The goal is to be arbitrage-free, but one of the concerns with models that have too few parameters is they implicitly allow arbitrage because they don't exactly price the securities in the market. So the extent that there's a discrepancy between the model price and the market price, implicitly you have a model that allows arbitrage in the real-world market. And in the Black-Derman-Toy model, the goal is going to be to fit this model. It'll have quite a few parameters we'll see. We're going to be able to fit this model in order to achieve 2 objectives. One is we're going to be able to price all the zeros in the market, and secondly, we're going to be able to define how much rate volatility exists at different points of the yield curve. And that'll be clear in just a moment as we move our way through this. The Black-Derman-Toy model is a model of short-term interest rates, as was the model of the prior module. Has a number of parameters in it, and it's intended to fit market information. So here's an example. And I note here, it's correct in the book, but on this slide, and I'm not able to correct it, that it says on the slide that the volatility is the volatility of the bond price in 1 year. That's not true. What we'll see is that the volatility is a measure of the volatility of the forward rate. So, for example, what we're saying is I have at a 2-year zero that has a price of has a yield of 11% and a price today of 81 cents. In 1 year, on a binomial lattice, that 2-year zero will be a 1-year zero, and it'll be in one of 2 states. And 10% is a measure of the volatility of the 2 interest rates implied by that. And that's what each one of these means. So that, same with the 3-year bond. The 3-year bond will be a 2-year zero in 1 year, and there will be 2 zero coupon bond prices in 1 year on the binomial lattice. And we want the volatility implied by those 2 yields to be 15%. So that's what these are. So our goal is to develop a lattice which prices zero coupon bonds exactly the same way today's market yields do, and with the property that when we look at these zero coupon bonds 1 year from now, we will see that the implied volatility of the rates 1 year from today is this sequence of volatility. So that's the market data we're going to calibrate to.